Hey everyone, I hope you're having a great day so far. I'm obviously not in class with you today, which is why you're watching this video. So in this video, I'm going to be demonstrating the lesson. You're going to take notes as you follow along with me. When you're finished watching the video, you will work on classwork that I assigned to you on Edulastic. You may not have the entire period to finish it, so just make sure you get that done before Sunday at midnight. All right, so today I will be covering standard and factored form of a quadratic function. You don't have a warm-up today, so you don't have to worry about getting a warm-up done, but you are going to take notes today, and then you're also going to get some example problems in. The example problems are optional to copy into your notes. You guys know the more example problems you have, the more equipped you're going to be for your quizzes because you can use those example problems. Once you're done with that, or watching this video, you're going to work on your classwork, which again is posted on Edulastic. Okay, so here's your page of notes. So what you want to do is pause this video right now and copy this down into your math notebook. All right, so you should have copied this down already. Let me go into this a little bit more. So we're learning two different forms. You have standard form and factored form. So the first one I'm going to talk about is standard form. We've been seeing quadratics in standard form. We've been seeing them last time when we saw the pumpkin example being launched on a catapult. You created them when you found the area of rectangular enclosures. So here is the standard form of a quadratic function. It's y equals ax squared plus bx plus c. And we're going to be looking at some of these, specifically A and C. We're going to talk about what those tell us about our function. We also have factored form of a quadratic function. In factored form, it's y equals A times x minus r1 times x minus r2. I'm going to talk about what r1 and r2 are right now. Notice that they both have an A value, our standard and our factored form. And I'll talk about what that's going to tell us in a little bit. Okay, so A, we see it in both of our forms. It's actually going to determine the concavity of the graph. We've talked about concavity before, but if A is positive, your graph is going to be concave up, which means you're going to have a minimum. If A is negative, that's going to mean your graph is concave down, which means you'll have a maximum. All right, so again, both of these graphs have an A value, and you're going to use that to determine the concavity and whether you have a maximum or minimum. The next thing is C. So you have a C, oops, I thought I was highlighting. You have a C value in the standard form. You don't see it in the factored form. But the nice thing about C is it tells you what the y-intercept is. So just by looking at your quadratic function, if you had a C value of 2, of -5, of 0, because you didn't have one, you could say, oh, that's my y-intercept. My y-intercept is 0 or 2 or -5. Remember that C is actually a constant. So that means it won't have a variable attached to it. The last two things are R1 and R2. Now, these are very interesting, and we're going to talk about these a little bit later, but R stands for roots. And what roots are they're actually the x-intercepts of your function. So it'll tell you where your graph crosses your x-axis. Your factored form is the only one that has an R1 and an R2, so you'll be able to determine those easily. All right, let's go ahead and see this into play with some practice problems. Okay, so for these practice problems, we're asked to determine from the equation whether each quadratic function has an absolute maximum or an absolute minimum. Explain how you know. Okay, so here is the first example. We have f of n equals 2n squared plus 3n minus 1. By looking at this, I could tell my equation is in standard form, so let me write that up here for now. So standard form is y equals ax squared plus bx plus c. So when we're doing these types of problems where we have to determine whether we have a maximum or minimum, you want to look at that a value, because remember from the previous slide, we talked about how a tells us what the concavity is of the graph, so we know what way it's facing. All right, so for each of these, we're going to look for that leading coefficient. We're looking for that a value. All right, so for part A, I could see my A value is 2. And I'm really just looking at the sign of it. Okay, so I know that my A value is greater than 0. It's positive. Okay, so because my A value is positive, it's greater than 0, my parabola is going to be concave up, which means I have a minimum. So this one has a minimum because our A value is greater than 0. Okay, and it's as easy as that. Let's go ahead and look at another one. So for B, again, this is also in standard form. My A value is negative. It's -2. So I'm going to say my A value is less than 0 this time. That means my graph is going to be concave down, and I'm going to have a maximum. So this one has a maximum because our A is less than 0. All right, let's try some more. For C, this one's also in standard form. Look at your A value, leading coefficient in front of x squared. This one is negative, so A is less than 0. That's just an easy way of saying it's negative. And because it's negative, that means graph is concave down. We have a maximum. So for this one, we have a maximum because A is less than 0. Next one is in factored form. Okay, so for this one, we have something in factored form, but again, factored form, just want to look at the front. That's where your A sits. It's A times your x minus R1, x minus R2. So we're only looking at our A. Our A is less than 0. So the same thing, parabola is facing down. We're going to have a maximum, and that's because our A value is less than 0. Next example is also factored form. We have the 1/3, okay? That is a value that's greater than 0, so it means it's positive. Parabola is facing up. We have a minimum, okay? Because A is greater than 0. Our last example, this one looks a little crazy. This is technically in factored form. So you can actually look at this two different ways. This is in factored form because technically this x, you're not subtracting anything, which is the same as saying I'm subtracting 0. Okay, and then these could be switched around. We're not going to do that right now, but you could. So you can kind of see it like it's in factored form. Another thing you could do is you can actually distribute this in. Okay, so I'm going to go ahead and distribute this in. I think that's the best way of doing this, honestly. So go ahead and multiply it in. 2x times 1 is 2x. Then 2x times negative x is negative 2x squared. Because we have the x times x, that's x squared. Rewrite this, j of x equals. Now, this one's interesting because it's not in standard form. My leading coefficient is not at the front. And I know that because my x squared is all the way in the back. So what I'm going to do is I'm going to change the order. This needs to be written first. Okay, it needs to be in descending order. So I'm going to say j of x is equal to negative 2x squared. Now I'm going to write this 2x, but it's positive, so I'm going to put plus 2x. So sometimes you just need to either distribute things in or turn it into factored form, but because we haven't really done that yet, I would say just go ahead and distribute. I could see my A value is negative, and because my A is less than 0, that means my parabola is facing down, and I have a maximum. Okay, so sometimes you might have to manipulate these a little bit to change the order. All right, let's go ahead and try some more practice problems after we look at this next page of notes. So what I want you to do is I want you to pause this video and then copy this down. The graphs, you can just do a quick sketch of them. All right, so you should have this in your notes. So I'm going to go over everything that's on here. So the first thing I'm talking about up at the top is the vertex. So the vertex of a parabola is the highest or lowest point. It's also known as the maximum or minimum. Now, when we wrote the vertex before, we were writing it in the format of an x and a y, which we technically still are doing that, but now our vertex actually has a special name. It's h comma k, where h is the x coordinate, k is the y coordinate of your vertex. So h comma k is specific to the vertex. The axis of symmetry is still the same. So the axis of symmetry of a parabola is a line about which the parabola is symmetrical. Same thing we talked about in previous lessons. So the nice thing is we can actually use algebra to solve for the axis of symmetry and the vertex. So again, because we're learning two forms right now, standard and factored, there's two different ways to do that. So the first one is standard form. Okay, so if you have a parabola in standard form, you can find that axis of symmetry, that red line in the middle, by using this equation down at the bottom. So it's h, remember h is the x-coordinate of your vertex, is equal to negative b over 2a. This b you get from your formula. This a you get from your formula. So you're just going to take those and plug them in to our h equals negative b over 2a formula to find that axis of symmetry. For factored form, you have a different formula. So remember, for factored form, you actually have the roots. Now, I want to talk about this a little bit. Roots are always going to be the same distance away to the axis of symmetry. They're always the same distance away. In this picture, they're each only 1 unit away, okay? So there's actually a formula you can use for it. It's kind of like taking the average. I don't know why it moved me all the way up. But what you're going to do is you're going to take the average. So you're going to add both of your roots together. So you can see R1 plus R2. Then you're going to divide it by 2. So that's how you find H, which again is the x-coordinate of your vertex, okay? To find the vertex, so if you only have h, to find k, you substitute h back into your equation to solve for that k value. Let's go ahead and try some practice problems. So for this first part, it says determine the vertex of each parabola. So our first equation is in standard form. They're telling us what the axis of symmetry is. The axis of symmetry is x equals negative 1. What we're going to do is we're actually going to take that x equals negative 1 and substitute it in for every x that we see. So I'm going to have f of, let me change this, it's a little too bold for me. So f of negative 1 equals negative 1 squared plus 2 times negative 1 minus 15. So all I've done, replace every x with a negative 1. So you want to plug that in to see what the y-coordinate of the vertex is. Rewrite the f of negative 1 on the left side. That's always going to stay like that for now, is equal to negative 1 squared is positive 1. 2 times negative 1 is negative 2 minus 15. From here, I'm just going to subtract from left to right. F of negative 1 equals 1 minus 2 is negative 1 minus 15. F of negative 1 equals negative 1 minus 15 is negative 16. So this is my y-coordinate of the vertex now. Okay, so here, let me use a different color. So this is my y-coordinate, which is technically my k. The axis of symmetry is technically my h coordinate. So let me highlight those. That's my h. Here's my k. I can write my vertex. So my vertex, remember, is in the form h comma k. So my vertex for this problem is negative 1 comma negative 16, and that is my answer. I'm going to highlight those so you could see where I'm getting this from. All right, so let me go ahead and try another one. So the one on the right is also in standard form. We're given the axis of symmetry, which is, remember, our h coordinate. We need an h and a k to fill in our vertex. So I need to take this h or this x and plug it in. So I'm going to have f of 4 equals 4 squared minus 8 times 4 plus 7. Remember to use parentheses when you're substituting. So I have f of 4 equals 4 squared is 4 times 4, which is 16, minus 8 times 4 is 32, plus 7. Keep bringing stuff down. Let me highlight to show you where I got this 4 from. I just plugged in. F of 4 equals 16 minus 32 is negative 16. Bring down the plus 7, and then do that subtraction. So f of 4 equals negative 9. Okay, so now all I'm going to do is write my answer. This is technically the k that I just found. So I'm going to go ahead and highlight that and write it in my answer. So again, my vertex is always h comma k. So my vertex is 4 comma negative 9, and that is my answer. Okay, so again, for these equations, for number 1 and 2, we were given an equation, we were given an axis of symmetry, and with those two things, you can use it to find the vertex. All right, let's look at the next two examples, which are the last two. So for the last two, we have to determine the axis of symmetry and the vertex of each. So this time we're just given an equation. We need to do both. So for the first one, you have f of x equals x squared plus 6x. This is in standard form. So remember, for standard form, if you don't have the axis of symmetry, you can find it using the formula you wrote. So it's x equals, oops, it's not x, it's h equals negative b over 2a. Okay, h is the x coordinate of your vertex. So what I'm going to do is start plugging in. Okay, so let me go ahead and label first, actually. So technically, standard form is y equals ax squared plus bx plus c. Okay, so I'm just going to highlight, see where things are coming from. My a, it looks like I don't have one. And I do. It's technically 1. Remember, if there isn't a coefficient, it's 1, kind of as a placeholder. My b is 6, and I don't have a c value. So if you don't have a c value, that means it's 0. So my c is 0. So let me go ahead and match that with my equation. Notice that in my equation, I didn't even need a c. So I'm just going to plug in what I have. Okay, so I'm going to have h equals negative 6 over 2 times 1. There's my 1. There's my b, which is 6. All right, so now I have h equals negative 6, 2 times 1 is 2, and then I divide that. H equals negative 6 divided by 2 is negative 3. That's my x coordinate for my vertex, which is technically my axis of symmetry. So my axis of symmetry is x equals negative 3. Remember, you need to write it as an equation. I still need to know my vertex. I have the h. I need to know what k is. So again, to find it, you just take your h that you found and plug it into your equation. So I'm going to take this and plug it in. So I have f of negative 3 equals negative 3 squared plus 6 times negative 3. Rewrite it. F of negative 3 equals negative 3 squared is 9. 6 times negative 3 is negative 18. Next step, I just do the subtraction. So f of negative 3 equals negative 9. That's my h coordinate. I'm sorry, my k coordinate. Okay, so that means k is equal to negative 9. So I'm going to plug that in there. And that's my answer. That's my axis of symmetry. That's my vertex. All right, I have one more problem to do. This one is in factored form. So let me write factored form up here really quick. Okay, so we have, let me erase a little squiggly on top. We have y equals a times x minus r1 times x minus r2. So let me just go ahead and write some of these things down. I have an a of 3. Now r1 and r2, okay? So r1 and r2 come after the minus sign. Now, for R2, that's super easy to see, okay? It's just 2. It's not negative 2 because it comes after the minus sign. Now, for this first one, for R1, I don't have a minus sign. And the reason I don't have a minus sign is because my 4 is actually negative. Because a negative times a negative is a positive. So that means for R1, I'm actually going to use negative 4, even though it says positive 4. You kind of take the opposite of what's inside for now. Think of it that way for now. All right, so what we're going to do is go ahead and use our formula. So our formula is h equals r1 plus r2 over 2. You add your two roots together, divide by 2. So let's plug those in. H equals negative 4 plus 2 divided by 2. We get h equals negative 2 divided by 2, which equals negative 1. That's our axis of symmetry. So our axis of symmetry is x equals negative 1. So that's one answer. We still need to know the vertex. We know the x coordinate. So our vertex, oops, I'm getting really messy, is negative 1 comma something. So again, to find what that something is, you're going to take the h we just found, sorry. Oh, Great, it erased everything. We're going to write the h we just found, which was -1, and we're going to plug that in. Okay, so let's go ahead and plug that in. So I know everything got erased. I'm so sorry. I don't know when my tablet does that. But we had h equals -1, which means I'll write this over again. Our axis of symmetry is x equals -1. That's one of our answers. And then to find the vertex, it's going to be -1 comma something. So to find that k value, you're going to take h and plug it in, plug it back in. So let's go ahead and walk through that together. So I'm going to have f of -1 equals 3 times -1 plus 4. I don't have enough space. Let me move this. Oops, took on my ruler. Don't know why. Let me move stuff over. Move this over that way, since I have nothing there anyway. And then let's move this over as well. There we go. Okay, and then times -1 minus 2. All right, so I want to figure out what's happening on the right-hand side. So I'm going to take care of the insides of the parentheses first. Remember, follow your order of operations. F of -1 equals, leave that 3 outside. In my first set of parentheses, -1 plus 4 is 3. In my second set, -1 minus 2 is -3. Now you're going to multiply these together. F of -1 equals 3 times 3 is 9. Bring down your -3. 9 times -3 is -27. That's my k coordinate. Okay, so my answer for my vertex is -1 comma -27. So if you didn't get this second to last problem, you can rewind it back and pause it if you want to copy it. Remember that the example problems are optional to copy down, because you can always go back to this video and reference them as well. All right, so what you're going to do is the classwork. It's posted on Edulastic. You have 5 problems to do. You have the rest of the period to work on them, so log in and work on that. If you don't finish, this is due on Valentine's Day, which is Sunday the 14th by 11:59 p.m. I don't know that you want to do this on Valentine's Day night. I mean, unless you love math, but anyways, I hope you guys have a great day, and I'll see you next week.